Good to all of you. The session is regarding intermediate, where we are going to discuss in detail about the intermediate chemistry that is fetching for your international entrance and competitive exams as well. India is conducting JEE Advanced and JEE Mains examination in the technical domain, that is for IET and NIT entrance exams. Medical stream will be there. All across India, NEET exam will be conducted by National Testing Agency that will be fetching for medical entrance. Telangana and Andhra Pradesh government are conducting the exam called MSET that will be give the admission into the BTech stream. Again, it is the technical domain. If you're aspiring competitive exams, there will be a content that will be very much fetching whatever we are discussing here. Common question paper general studies will be there. In that you can find the questions related with the content what we are discussing now. Let's enter into our today's session. The question one will be started with Nobel chemistry in the year 2018. The Nobel Prize in the field of chemistry in the year 2018 was accorded to the scientist H. Arnold for the direction of evolution of enzymes, the other half jointly to the George Smith and Sir Gregory P. Winter for the phase display of peptides and antibodies. So this is the kind of cumulative work they together accorded with the privileged all over world recognized prize called Nobel Prize in the year 2018 in the field of chemistry. These three scientists, among these, Francis H. Arnold contributed half of the work for this Nobel laureation, and remaining half was shared by George Smith and Sir Gregory P. Winter. Right? Let's go with the detailed comprehension of this Nobel Prize accordation. Frances H. Arnold, she is the winner of half of the percentage of Nobel Prize for the year 2018 in the field of chemistry. George B. Smith is one by fourth contribution. Sir Gregory Winter is also the part of this one. Franz Harold Arnold contributed from the California Institute of Technology, Pasadena, USA. So she contributed from the California Institute of Technology, and she awarded with this Nobel Prize in the field of chemistry for the directed evolution of enzymes. This is related with the biomolecules, and in turn we can say biocatalyst, right? And other half is jointly for George P. Smith, University of Missouri, Columbia, United States of America, Sir Gregory P. Winter, MRC Laboratory of Molecular Biology, Cambridge, United Kingdom. For the phase display of peptides and antibodies, their work is contributed for outstanding research and analysis in the field of biomolecules and living process, right? So that's the reason why this is accorded for these three scientists together. They harness the power of evolution. So power of evolution was done by these three scientists together. The power of evolution seems to be whenever you are moving from past generation to present generation, there is certain kind of change you can notice that is said to be evaluation, and whatever change you can see, that is the kind of advancement, that is the kind of upliftation. Always as the time surpasses, what happens, there is a kind of changes in your environment, in your thought process, in your workability, in your living standards. Everywhere you can find that kind of changes, that kind of advancement, which is said to be evolution. As we are what is starting from the whenever the life started on the earth, and especially that will be started in the muddy ooze, so in the water, that is in the muddy water, in that living organism what existence got started over, and further that is going with the so many kind of morphological action by means of climate, by means of surrounding condition, by means of environment, by means of society. Everywhere there is a kind of interaction, so that there is a kind of advancement you can notice. So that evaluation is continuous process. As you're moving with the time, though you're not noticing, but there is certainly a kind of change is possible from time to time, right? That is said to be evolution process. That evolution is purely confined, purely understood by these scientists together through the life process. In the year 2018, Nobel laureates in the chemistry have taken control of evolution, used for the purpose that bring the greatest benefit to the mankind. So whatever evaluation is going on, that was taken in the right direction by these scientists together, so that that will give the highest benefit to the mankind in the direction the research was done. That kind of analysis was taken into the consideration. Enzymes produced through the directed evaluation are used in the manufacturing everything from the biofuels to pharmaceuticals. Okay, enzymes are very much important. Even you are going with a simple reaction to the multi complicated one, everywhere the purpose of enzyme is most important, especially in biomolecules, because enzymes mostly deal with the biomolecules, so that in that biomolecules all the actions will be carried in a proper time, and a proper functioning is possible by the secretion of these enzymes only. Enzymes are said to be biocatalysts. They can felicitate the rate of the reaction, so that they are very essential. Antibodies evolved using the method called phase display can combat the autoimmune diseases. Some of the autoimmune diseases will be there. So defensive system is there in your body, that used to protect your body from all kind of pathogens whoever trying to enter inside. So that that autoimmune system is available for each and everyone. That's why we are surviving, though so many kind of pathogens are there in your surroundings. But whenever any kind of circumstances are present, sometimes there is a kind of system where your immune system will be disturbed, so that the pathogen will enter into your body, and that causes so many kind of diseases. But the thing is, they are used to focus on antibodies. Antibodies are the kind of defensive weapons, we can say, in the living organisms. So they got evolved, they got evolved. So by means of the process called phase display. So this phase display process was utilized in order to develop these antibodies. So these antibodies are protective devices in order to avoid these autoimmune diseases. They will work, they will fight against autoimmune diseases. And even this kind of antibodies will curate, will work in the curation of metastatic cancer as well. So this is the way a multifaceted applications you can notice for the kind of research what they have done, so that it is most applicable kind of research towards the mankind. Since the first seeds of life arose in, around 3.7 billion years ago, which is a very ancient time, we can say. At the time, no civilization, nothing is known to the living organisms. At the time, 3.7 billion years ago, the life got started on the earth. Almost every crevice in the earth has filled with the different organisms. So here different organisms got evaluated in different regions. Life has spread to hot springs, deep oceans, and dry deserts, and because of evolution has solved a number of chemical problems. There are so many type of environmental categorization confinements you can notice. Everywhere there is a existence of living organism, and they have their own adaptations in order to survive in that particular region. So that different kind of regions, environmental conditions are confined with the various kind of living organisms all over the world. Life's chemical tools, proteins, have been optimized, changed, renewed, created incredible changes, right? So here everybody aware that protein is very essential for healthy growth. Even after the growth also, the people are supposed to consume the proteins on daily basis. There is a certain level of protein content in the human body. In your meal you have to ascertain with that kind of protein, because they are very essential to build your body and strengthen your body as well. So that there are so many kind of research attributes in the field of these proteins, so that protein structure got optimized. So whatever required, that kind of protein morphalization got carried over, and changes got arrived in that protein synthesis and protein existence, and there are new kind of proteins also introduced, renewed, are created. Entirely new one can be synthesized, so that there are multiple protein manufacturing got carried, which having their own way of applications in the living organisms. The year 2018 Nobel Prize laureates in chemistry have been inspired by the power of evaluation, how the changes are going there. So everywhere there is a kind of advancement we can notice. In accordance with that, there is a kind of changes in this what enzymatic action and even antibody technology to be evaluated. The evaluation taken into the prime concern regarding their focused area for the exploration, right? So this evolution and use the same principles, genetic change and selection, to develop proteins that solve the mankind chemical problems. Whatever problems they are facing with respect to the chemical domain, they are facing the problems. By means of this, by the context of this evolution process, they made genetic changes, and there are kind of modifications in the field of peptide linkages. Antibody development got carried, and they use the technology called phase display. By means of this process, this evolution of enzymes get carried over, which was a huge success in the field of research and evaluation process as well, so that it was accorded with the most prestigious prize of the world, called the Nobel Prize for the year 2018 in the field of chemistry. Move on to the question number 2. It is not the question, rather we collected the most important content in order to identify these ions, what kind of chemical reactions we are supposed to carry over. Okay, by using two common reagents, what kind of changes you can notice, what inference you will draw with these cationic species. Okay, so it is simply said to be a qualitative analysis of cationic species. In the earlier session, we gone through with the various anionic species. How can we analyze, how can we identify them? So this is the way, this is the part of salt analysis, we can say, and moreover qualitative analysis part. Okay, let's go with the test of these cations and the relevant inference, what you can notice by means of the reaction with sodium hydroxide and subsequently with the aqueous ammonia. So these two are the individual tests, not followed by test. Both we can say aluminum independently treated with sodium hydroxide in one test tube and aqueous ammonia in another test tube, so that you can notice the changes. Based on that, you can identify what cation is present in the given mixture. So let's move on to this concept what we are discussing now. First of all, we are considering this aluminum, which is accorded with aluminum plus 3. If the given salt is having aluminum plus 3, how can we identify this is the salt containing aluminum plus 3? Take the unknown solution of aluminum plus 3, add in the suitable solvent, and a few drops of sodium hydroxide will be mixed up. After mixing the sodium hydroxide in the dry test tube, what happens? You can notice the white precipitate. That precipitate upon dissolving the larger extent of water, so that colorless solution will be noticed. Initially, precipitate is formed after the addition of excess of water, so that entire precipitate got dissolved in that. So this indicates what, there may be a presence of aluminum plus 3. You got the initial seeding idea about that one. Later on, we will go for the confirmation. You can go with the reaction with ammonium. Whenever unknown aluminum solution and the dissolved in the suitable solvent and a few drops of ammonia got mixed over, whenever ammonia is added, immediately you can notice the white precipitate in the test tube, so that even by the addition of water it will not be soluble. So that white precipitate formation confirms the presence of aluminum plus 3. This is the way aluminum can be identified. Ammonium, this is the most important test for the identification of cations. So ammonium, whatever ions you have among all the cationic species, ammonium test will be conducted first, because there is a kind of reagent ammonia is there. So that in order to avoid the ambiguity, first of all we have to identify whether the given salt is having ammonium ion in that or not. That's why everywhere ammonium ion cationic test will be performed first before going for the cationic analysis, right? This ammonia test can be performed with sodium hydroxide. Whenever ammonium ion containing solution is added with sodium hydroxide and placed on the Bunsen flame, gentle warming is required so that ammonia gas will be evolved. Pungent smell ammonia gas will be evolved. By smelling only you can identify, or else you can go for the litmus test. Red litmus is placed on the ammonia effervescence so that you can observe the change red color into a blue one. This is the way ammonium ion can be identified. Ammonia can't be analyzed with ammonia again, so that put a dash mark over here. Then move on to the identification for the calcium plus 2 ion. Calcium plus 2, upon treating with sodium hydroxide, there is a origination of white color precipitate. Milky white precipitate will be generated within the test tube at the bottom, and even by the addition of excess of water will not be disappeared, being it is the water insoluble, right? So that calcium, upon addition of sodium hydroxide, calcium hydroxide formed, that is a white color precipitate. Even everybody know whitewash, what we are using for homes. So that whitewash made up of calcium hydroxide only, right? So whenever ammonia is added to the calcium plus 2 ion, you can't notice any precipitate. A very slight white precipitate will be formed. No precipitate will be formed. So by this only you can clearly identify this is the calcium plus 2. Chromium plus 3, sodium hydroxide reaction gives rise to a green color precipitate over there at the bottom. Green color will be noticed. Even by addition of excessive amount of water, that green color is becoming fade and completely soluble in water, right? So chromium will react with sodium hydroxide, gives a chromium hydroxide, that will be a green color precipitate. Even with ammonia, that able to give a green color precipitate, so that water insoluble green color precipitate will be formed. Copper plus 2. Copper plus 2 upon addition of sodium hydroxide giving copper hydroxide, that is blue color. All copper plus 2 complexes are generally said to be blue color in nature and insoluble in excess of water, so that blue color persisted. Even the addition of excessive amount of water, blue color will not be disappeared. And even ammonia reaction giving a blue color precipitate, that is soluble in the excess, giving a dark blue color solution. Precipitate will become a solution type, but it is again existing in a blue in color because copper plus 2 is a blue color pigment. If you go with iron plus 2, able to give a green color precipitate just like a chromium plus 2. Chromium plus 3 giving green precipitate in the same manner. Iron plus 2 also gives the green color precipitate with the sodium hydroxide. And even an addition of water, that will not be removed, that will not be disappeared. It will be persisted and near the surface of standing. Again, ammonia reaction giving a green color precipitate, brown near the surface. Whenever excess of water is added, the green turned into a brown in color. Even after long time also, brown color will be persisted. That will not be disappeared. There is a drastic difference between the ferrous to ferric. You can go for distinguishing ferrous from ferric. Ferrous will give green color precipitate with sodium hydroxide, whereas ferric will give red brown color precipitate. And ferrous with ammonia gives a green color. Again, ferric will give red brown color precipitate with the ammonia solution, right? Zinc always, being it is a D10 system, so that you can notice white precipitate, white precipitate. Wherever zinc is there, you can notice white precipitate only. So this is the way various chemical reactions and there is subsequent identification got cleared, and we will go with the detailed explanation for the same. Aluminium if present, and the reaction with the sodium hydroxide giving sodium aluminate. Sodium aluminate is a white color precipitate. Even addition of excessive water, that precipitate will be soluble, and precipitate disappeared, and colorless solution you can notice, that is sodium aluminate. And aluminium, upon treating with ammonia, there is a formation of aluminium hydroxide solid. You can observe it is a solid compound which gives the milky white in color. You can notice in this test tube. Ammonium ion, if treated with hydroxide or sodium hydroxide, that used to release the ammonia gas. Ammonia gas can be identified by litmus test. Red litmus turned into a blue one. Sodium hydroxide test for what? Calcium. So whenever calcium is reacted with sodium hydroxide, these calcium ions are able to give the precipitate which resembles milky in white color. At the bottom, you can notice clearly. And even reaction with ammonia, that calcium is able to give a white color precipitate. So this exactly resembling with the barium. Barium plus 2 also able to give the same kind of precipitate at the bottom upon treating with ammonia. Calcium and barium are similar in this ammonia test. Move on to chromium plus 3. Chromium plus 3 upon treating with alkali, that means sodium hydroxide, it is giving a green color precipitate. You can clearly notice here, right? Ammonia solution giving a pale green color. Chromium hydroxide will be here also, chromium hydroxide will be formed here also, chromium hydroxide, but it is somewhat light in color, right? Move on to copper plus 2. Copper plus 2, obviously it will be a blue in color substance. Whenever treated with sodium hydroxide, copper hydroxide will be formed, that is existing in blue color. Then copper upon treating with sodium hydroxide giving blue color. And even ammonia reaction also giving a complex, copper ammonium complex will be formed, that complex again existing in deep blue color, right? Then move on to ferrous. Ferrous is the kind of a green colored solution. Upon treating with sodium hydroxide, ferrous hydroxide will be formed as the product. This ferrous hydroxide again existing in green color precipitate. Ferrous hydroxide, iron 2 hydroxide, and the Roman numeral, whatever mentioned, is called its oxidation state around the central metal. And its existence is like this. You can clearly observe iron plus 2 upon treating with ammonia, it able to give red brown color solution, right? Ferrous upon treating with ammonia, there is a formation of ferrous hydroxide that able to give red brown color precipitate at the bottom of the test tube like this. Move on to ferric. Ferric is a kind of a red color pigment. Everybody are having, all human are having red color blood, right? That is because of ferric ions in your blood. Hemoglobin is a coloring pigment over there, and ferric ions upon treating with alkali, that means sodium hydroxide, that gives rise to the ferric hydroxide. Ferric hydroxide existing in a red brown color precipitate. Even ammonia test also giving ferric hydroxide, whatever ferric hydroxide, that is giving red brown color precipitate. So both the reactions are giving same product for iron. This is the identification and subsequent conformation for ferric ion. Move on to zinc. Zinc always D10 system, so that no question, there is no other color. There is no other color for the zinc, because completely filled orbitals are having high stability. DD transitions are absent and charge transfer spectrums are absent, so that you can notice a white color precipitate over there. Upon treating the zinc with sodium hydroxide, sodium zincate will be formed. The sodium zincate existing in a white color. Even zinc treated with ammonia under water conditions giving, sorry, zinc hydroxide will be formed. Again, it is the kind of solid or white precipitate. It is forming a milky white color precipitate. This is the way all the cations got identified, and the distinguishing test also mentioned with their colors in a clear manner. Practical observation we gone through, so that it is giving more clear portfolio of cationic identification. Move on to question number 3. Question number 3 was collected from JEE Advanced 2016 paper 1 question paper. On complete hydrogenation, natural rubber produces. Rubber can be synthesized from the nature, because rubber plantation is available. How we are collecting the gums and the glue from the plant material, in the same way rubber is also collected from the plant material in the form of latex. Hevia brasiliensis is a kind of plant where the secretion of latex is noticed, and so many series of chemical reactions got carried, so that finally it is converted into a rubber material. So what we are using, this natural rubber is supposed to be hydrolyzed, so hydrogenated, not hydrolyzed. Hydrogenated means reduction. Upon reduction, what will be the product? There is a possibility of ethylene propylene copolymer. So mixture of two compounds will be generated upon hydrogenation. Natural rubber is composed by 2-methyl 1,3 butadiene, which is familiarly known as isoprene. So isoprene is the monomer for the polymerization, and you can achieve this natural rubber. This natural rubber is supposed to be hydrogenated by means of hydrogen nickel, so that whatever double bonds are there in between all get saturated, and you can notice all the single bonds only. These single bonds, whatever we can be started with the one of the unit called ethylene, another unit called propylene. So ethylene and propylene are the monomeric units for the copolymerization. So that this is the expected answer for the hydrogenation of natural rubber. Move on to option number B, vulcanized rubber. The vulcanization of rubber is said to be whenever rubber is added with the powdered sulfur, so that it will be participating in a cross linking, which is called a vulcanization. And polypropylene is generated whenever we are having the 3 carbon chain, but natural rubber is a 4 carbon with the one side chain methyl. So no way possibility for option C. And move on to polybutylene, only 4 carbons, but natural rubber is composed by 5 carbons. We can say isoprene unit. So polybutylene may not be a correct answer. Only the possibility is option A, ethylene propylene copolymer. So that is clearly depicted in this schematic representation. One is ethylene carbon-carbon double bond, propylene with the carbon-carbon double bond, and methyl group over here. This is the way we can answer this question number 3. Move on to question number 4. According to the Arrhenius equation, a high activation energy usually implies a fast reaction. Rate constant increases with increase in the temperature. This is due to the greater number of collisions whose energy exceeds the activation energy. Higher the magnitude of activation energy, stronger the temperature or dependence of the rate of the reaction. Pre-exponential factor is the measure of rate at which collisions occurs irrespective of their energy. This is the question given from physical chemistry, and in specific, you can go with the thermodynamics. Arrhenius equation is taken into the consideration. First of all, let's see what is Arrhenius equation. The Arrhenius equation uses the temperature dependence of the rate constant to determine the activation energy. So it is the correlation between the how rate constant is related with the temperature. That relation is mentioned by the scientist called Arrhenius. It is given by the equation K is equal to A into e to the power minus EA by RT. A denotes what? Rate constant. A is the Arrhenius constant, which is called a frequency factor, and E is the exponential factor. EA is called activation energy that is required in order to pass from reactant to product. There is a kind of in middle destination point, which is called activation energy. The molecule who are crossing activation energy can be converted into a product, otherwise again bounce back into the reactant species only. R is said to be gas constant, is called temperature on Kelvin scale. So this is the way Arrhenius equation is mentioned. K is equal to A into e to the power minus EA by RT. In this equation, reactants are supposed to reach this in middle destination called activation energy, then only they can fall into the product formation, right? So whenever activation energy is larger, it's very difficult to reach out the products, because in order to reach this activation energy, that the maximum threshold they have to move on, that requires very large amount of energy, so that molecules are not susceptible to go into the product side, rather they go back into the reactant side. Whenever any enzyme is added, catalyzed reactions you are going through, so that activation energy got minimized. Whenever activation energy got minimized, so that reactant conveniently reaches this in between destination point and finally converted into a product side, so that rate of the reaction is inversely proportional to activation energy. More the activation energy, that is very difficult to reach out the product side, so that rate of the reaction inversely proportional to higher the activation energy, lower the rate of the reaction. What they mentioned in the option 1 is incorrect. High activation energy usually implies fast reaction is the wrong one. Low activation energy goes the faster the reaction, because they can easily move on to that higher energy barrier and go on to the product side, right? And next explanation is Arrhenius plot show that reaction rates are inversely proportional to the temperature changes, so that rate constant increase the temperature, rate constant increases with increasing temperature may not be the correct one. Higher the magnitude of activation energy, stronger the temperature dependence. This we will go with temperature dependence, right? So here, higher the activation energy, higher is the required temperature for the reaction to occur, hence greater is the temperature dependency of the rate of the reaction. This is the data collected from toppers.com, right? So that higher the higher the magnitude of activation energy, so that temperature is required, external temperature to be supplied, then only that reactant molecules will achieve that higher activation, and they are supposed to move on to the product side, so that is the temperature dependency of the rate of the reaction will be increased by means of higher activation energy, right? And move on to explanation for the factor number 4, frequency factor. The pre-exponential factor is also known as a frequency factor. Pre-exponential factor, whatever there, that is also denoted as a frequency factor. And frequency factor of collision between the reactant molecule at a standard concentration. Concentration taken as the optimized condition, and how the collisions are carried among the reacting molecules, often described as temperature dependent. Temperature dependent, more the temperature, more the number of collisions. You can notice it usually depends upon the temperature, because it is related with the molecular collisions and the function of temperature, right? So here always the reactant molecule collisions purely taken on the temperature dependency. As we are rising temperature, the probability for that collision will be higher at a standard concentration conditions. Pre-exponential factor is the measure of rate at which collisions occurs irrespective of their energy is the perfect answer, right? So this is the way we can answer the question number 4. C and D are the correct answers. Move on to question number 5. Question number 5 is collected from inorganic chemistry. In specific, we will treat it as a chemical bonding with respect to molecular orbital theory. In order to explain about type of bonding among the molecules, there are so many theories. Molecular orbital theory we are taking into the consideration here. Identify all the species that do not exist. So the molecules which are not susceptible for their existence, that to be identified. Hydrogen 2 positive ion, helium 2 positive 2, lithium 2 negative 2 ion, neon 2 neutral, beryllium 2 negative, helium 2 neutral. Among these, which are not susceptible for their existence to be identified. For that, we are having the correct answer. Lithium 2 -2, there is no provision for the existence. Neon 2 is the noble gas. Moreover, it exists in the monoatomic. Diatomic is not at all preferable. And helium 2 is also the kind of noble gas, so that it is monoatomic, being it is more stable configuration. Noble gas configuration is accorded. Okay, so these three are not existing in a dimeric form, right? So these non-existence of the molecule purely explained by molecular orbital theory. If bond order is taken as 0, so that existence is not possible, not feasible, right? So let's move on to the compound one. Whatever mentioned, everyone we will apply the molecular orbital theory, so that we will check whether molecule is existing or not. If you go with the hydrogen 2 positive, hydrogen atom taken one side with 1 electron, hydrogen plus without any electron. Hydrogen plus means being it is 1 electron species, if you remove that, so that 0 electrons you can notice. So that bonding molecular orbital is resided with only 1 electron, so that helium 2 positive is having only 1 electron in that entire molecular orbitals. Apply the bond order formula. Bond order formula is half and number of electrons residing in the bonding molecular orbital minus number of electrons residing in the star antibonding molecular orbital. So that half into number of electrons bonding are 1 only. Antibonding, you can't find anything, 0 you can put over. So that 1 minus 0, 1 only. 1 by 2, 1 into 1 by 2, 1 by 2 only. So in case of hydrogen 2 positive, the bond order nothing but how many bonds existing in the combining atoms. So half indicates the 2 hydrogens are joined together by half bond only, that is indicated with the dotted line, so that it is existing. Non-zero always existing only. If 0 is there or minus is there, that no way possibility. So that you can expect a hydrogen 2 positive ion in the nature. And move on to helium 2 positive 2. Helium 2 positive 2 means helium plus. Remove 1 electron from one helium atomic orbital, another from another helium atomic orbital. So it exactly resembling hydrogen atoms. And the bonding molecular orbital is having 2 electrons, anti-bonding 0. Then apply the bond order formula, half into bonding electrons are 2, anti-bonding electrons are 0. 2 minus 0 will be 2 only, no? So 2 by 2 it will be 1. bond order will become 1. So the 2 hydrogen positive cations are bounded by 1 sigma bond. So a single bond is existing in between bond order. Bond order explains about how many bonds existing in between two atoms. So this is the way we can answer helium 2 positive 2 ion. And move on to lithium 2 minus 2 ion. In that lithium 2 minus 2 ion, lithium atom is atomic number of 3, so that 1s2 2s1 will be there, but -2 if present, what happens, one of the 1s orbitals are contributing to 2 electrons, so that put 2 electrons in sigma 1s, 2 electrons in sigma star 1s. Then move on to 2s, being it is -2, so that to put 2 electrons here, actually 1 electron is there, but negative charge contributing 1 more electron. Here also lithium, another lithium is also having negative charge, because 2 lithium 2 negative charges, so that here also put 2 electrons. So 2s2 2s2, so 4 electrons can be contributed in sigma 2s bonding and sigma 2 star anti-bonding like this. So this is the way filling is carried in lithium 2 minus 2. After filling, apply the bond order formula, half into electrons residing in the bonding orbitals. This is a bonding orbital with 2 electrons. This is also bonding electron with the 2 electrons, so that 4 are residing in a bonding. Move on to anti-bonding. 2 are there in anti-bonding 1 is, and 2 are there in anti-bonding 2 is. So 4 electrons. 4 minus 4, it will be 0, no? 0 by 2, it will be 0 again. Any number divided with 0 is becoming 0 only, so that non-existence. So whose bond order is taken as 0, which is not susceptible for its existence. Lithium 2 minus 2 is non-existent. Move on to neon 2. Neon 2 is a noble gas. 1s2, 2s2, 2p6 is the completely filled octet configuration. Whenever completely filled octet configuration is there, 2s2, 2s2 electrons can be contributed in bonding 2, anti-bonding 2. Then 2p6, 2p6, 12 electrons can be distributed in such a way. 2p sigma 2pz with 2 electrons, pi 2px, pi 2py with 2 electrons, so pi star with 2 electrons, sigma star with 2 electrons. Apply the bond order formula, half into bonding electrons. 2 plus 2, 4, 6, 8. 8 are in bonding. Count the number of electrons in star orbitals. 2 plus 2 plus 2 plus 2. Total 8 again. 8 minus 8 will be 0, no? 0 by 2 again 0, so that neon molecule quantity existed. Being bond order is 0, neon 2 is non-existing molecule, because of completely filled electronic configuration will accord the exceptional stability for this molecule, which is the noble gas. Move on to beryllium minus 2. Beryllium minus 2 is nothing but one of the beryllium is normal only, another beryllium is of negative charged. Okay, beryllium atomic number is 4, no? So that put 2 electrons in 1s, 2 electrons in 2s, but one of the beryllium is having negative, so that put 1 more electron for beryllium negative. Another beryllium is 1s2, 2s2 only, 2p0. We are not having any negative charge for this second beryllium. So 2 plus 2 electrons will be contributed in 2 bonding, 2 anti-bonding, finished. Then 2s orbitals also 4 electrons will be contributed in sigma bonding, sigma anti-bonding, finished. This beryllium minus is contributing only 1 electron, that entered into pi 2p only. Only 1 electron will be there in a bonding orbital. Then count the bonding electrons. 2 plus 2, 4 plus 1, 5 electrons in bonding. 2 plus 2, 4 electrons in anti-bonding. So 5 minus 4, 1. 1 by 2 is half. So that beryllium 2 minus existing molecule only, existing ion only, but bond order is half, so that both the beryllium are joined by half bond only. So that you have to mention it with the dotted line bond. And move on to neon 2 completed. No, this is about helium. This is called helium. You can notice helium here. Okay, whenever helium atomic number is taken as 2, so that 1s orbital is resided with 2 electrons, and another helium also having 2 electrons, and total 4 electrons can be contributed into bonding to anti-bonding. Then bond order can be calculated by taking half into 2 minus 2. Bond order is becoming 0. whatever bond order is becoming zero, that molecule is not expected to be existed. So that helium 2 molecule is non-existence because of completely filled electronic configuration. Exceptional stability is accorded, so it is the noble gas. This is the way we can answer this all these questions. Among all, lithium 2 plus minus 2 is having bond order 0, neon 2 also 0, helium 2 also 0, so that these are non-existing molecules and the remaining all are existing, right? So for question number 5, option number 2 is the correct answer. Move on to the last question of the session. We entered into the conclusive part. The compressibility factor of the real gas at high pressure. The question collected from the physical chemistry part and mean specific gaseous state, right? So the expected answer for this question is 1 plus PB by RT. How can we achieve this? We will see about. Everybody aware about the van der Waals gas equation. P plus A by V square into V minus B is equal to RT. This A by V square is called pressure correction, and minus B is called volume correction. So P plus A by V square, V minus B is equal to RT is the real gas equation, which is also called as van der Waals equation, right? So at high pressure, if you are rising the pressure, so this pressure term is higher. Whenever pressure term is higher, whatever adding factor is there, that you can ignore, that will be neglected, because this is the larger term, no? So that A by V square will be neglected. At that condition, the equation will be concised into PV minus PB is equal to RT. PV minus PB is equal to RT. You can rewrite the equation as PB by RT is equal to 1 plus PB by RT. So this is the way at high pressure conditions 1 plus PB by RT is the expected answer that you got in the option number 4. For question number 6, option number 4 is the correct answer. Remaining may not be correct because it is exactly mapping with this option 4 only. This is the way we can go for this problem solving analogy and question framing. What weightage, what criticality will be the question, and how can we answer? What are the domains are suitable to get the questions more frequently? These many things came into the picture, and I'm sure, I'm very sure for that whoever following this kind of session regularly will definitely achieve whatever exam you're appearing in the level of intermediate. So that I'm requesting you to like the channel, comment. In order to comment about this one, we will have a question for the session. In the session, we gone with the various topics. Various things came into the picture. Let me ask the question based on molecular orbital theory. Can you please what is the criteria in order to mention magnetic nature based on molecular orbital theory? Some of the molecule, let me say oxygen is said to be paramagnetic in accordance with the molecular orbital theory. What is the criteria for that one? How can you explain the magnetic nature of the molecule based on molecular orbital theory? Let me repeat. What is the criteria to measure magnetic nature of the molecules in accordance with the molecular orbital theory? That can be posted in the comment box for the session and share with the aspirants who are more curious for the examination, and those who are following very regularly will definitely achieve the exams for sure. And subscribe the channel. Definitely we will go with the new content in the near future, and so many things will be added over there. Every day we will cover so many topics which are related with the examination point of view. Most repeated, most expected questions will be taken into the consideration. Thank you for watching. Thank you one and all.